Hello dear students, today we are going to discuss our new topic, that is slip gauge. That is one of the end standard, and it is very important end standard. So let us revise something about end standard. End standard is what? End standard is the standard that will measure the distance between the two parallel flat surfaces. If we have two parallel flat surfaces, so the distance between these two parallel surfaces is termed as end standard. So slip gauge falls under the category of end standard. So slip gauges or the gauge block are universally accepted end standard of length that is used in industries and at very other points in different labs. And these slip gauges are introduced by a Swedish engineer known as Johnson, and that's why this slip gauge is also called as Johnson gauges. They have high degree of surface finish and accuracy, and they are what? They are the rectangular blocks of cross section 30 mm into 10 mm, and they are commonly used and standard in the engineering field. It is also used for the angular measurement. If we do the angular measurement using sine bar, so there we use slip gauges. So the size of slip gauge is defined as the distance between two parallel faces. In this figure, it is given a diagrammatic representation of slip gauge. This is the face length and this is the face width. This is 30 and this is 10. This face length is 30 and this is 10. So this is the cross section of the slip gauge. This is 30 into 10 mm. And slip gauge length, this height is the slip gauge length. And each slip gauge is having its particular dimension. Let us suppose if a slip gauge is having the dimension of 1.0005 mm. So it means it is of only single piece in a box. Why I am saying in box? Because number of slip gauges are present in a box which is having different dimensions. Let us suppose if we talk about the first slip gauge which is placed inside the box, it will be 1.005 mm. Then next slip gauge is of other dimension. And if we want to make a dimension of, let us suppose, 15.0235, so we have to use number of slip gauges to make that dimension. So in this way, slip gauges is used. This is a brief introduction of slip gauge. Next, I have told you that for making a dimension, we have to use number of slip gauges. So how these slip gauges are combined together to form that dimension? That property of the slip gauge is called as wringing property. So we will discuss wringing. By wringing, suitable combination of two or more gauges combined together to form a dimension. If you want to make a dimension, then we have to club number of slip gauges, and there is a proper method of combining these slip gauges, and this is called as wringing in slip gauges. The phenomena of wringing occurs due to molecular adhesion between a liquid film that is present on the slip gauge and the matting surfaces. It means the sticking of the slip gauge will take place due to the molecular adhesion between the liquid film and the matting surface. The precision of the slip gauge depends on the successful wringing. If your wringing proper is very good, you have applied slip gauge to slip gauge, you have joined two slip gauge with the wringing property. So the precision of the slip gauge depends upon the successful wringing. The gap between the two pieces observed to be 0.00635 micron. This is a minimum gap which is present in between the two slip gauges when they are combined together, and this gap is of negligible nature. One gauge is placed perpendicular over the other gauge and is slide first, followed by the twisting movement which fits the gauges together. This is the method how the wringing takes place. So if you see this diagram, we will put one slip gauge over the other slip gauge in the perpendicular direction. Then in this part 2, when they put perpendicular to the others one slip gauge, then we have to give a twisting movement to the slip gauge which is placed over this slip gauge, and in this way your slip gauge stick together and successful ringing takes place. The overall thickness of the rung gauges is equal to the summation of all the individual gauges. It means if we use 5 slip gauge to make a particular dimension, then the summation of all the individual gauges will give you that final dimension which you want to achieve. So this is how the ringing takes place. I am just sharing you a YouTube video which will provide you the idea of ringing, how the ringing takes place. So wait for a minute.
Pieces of metal. They aren't magnetic and they don't have any adhesives of any kind. The surfaces are smooth and they don't have any noticeable grooves. I can press them together and they don't split. However, if I slide them together like this, they stick together like super magnets. They are clearly stuck together and I can't even pull them apart. If I twist them apart, they go back to being separate pieces of non-magnetic metal. What's happening? Well, these are actually gauge blocks, which are blocks of smooth metal that are precisely manufactured to speed certain lengths so machinists can calibrate their machining and measurement tools. They're extremely smooth surfaces of why they stick together. The thing is, nobody is certain about how they stick together. There are several potential explanations that most likely work together to create the effect. First of all, because there is nearly no air between the smooth surfaces when pushed tightly together, the air pressure loop might push in on both blocks. Second of all, the surface tensions from oil and water vapor on both blocks might hold them together. Finally, intermolecular forces might cause attraction since the surfaces are so smooth and molecules from the blocks are in such proximity. Gauge block ringing has been shown to work in a vacuum with clean blocks, and that is evidence that this is actually a factor. It's pretty cool that they're not.
So by this video, you will get the idea how the ringing in slip gauges takes place. So according to the Indian standard, there are 3 grade of slip gauges. First grade is grade 0, grade 1 and grade 2. Grade 0, grade 1 and grade 2. Grade 0 is of higher accuracy. Grade 1 is of lower accuracy as compared to grade 0. And then grade 2 is of very less accuracy. And grade 2 slip gauges are intended for use in workshop during the actual production of the component, tool and gauges. Grade 1 is of higher accuracy and used in inspection department. The inspection department use the grade 1 slip gauge, and grade 0 is the slip gauges that are used in laboratory and standard rooms, and it is used to check the accuracy of grade 1 and grade 2. So this is how the Indian standard of slip gauges are classified. Always the slip gauge are available in sets. They are available in sets. For example, if there is a box, and its name is M87, it means it is having 87 pieces of slip gauges. And how it is classified, this table shows you that this is the range. First column specify the range, second one is the step, and third one is the number of pieces. So range will give you 1.001 to 1.009. It means there are 9 number of slip gauges which is having the step of 0.001. It means like this: 1.001 mm, 1.002 mm, 1.003 mm. So in each, between the two slip gauges, there is a step of 0.01 mm. So there are 9 number of slip gauges. Next, 1.01 to 1.49. For this step is 0.01 and the number of pieces is 49. It means when we start from 1.01 mm, then 1.02 mm, 1.03 mm, and up till 1.49. So here the step is 0.01 and number of slip gauges is 49. In the similar way, there is a other set of slip gauge, that is 0.5 to 9.5. Step is 0.5 and number of slip gauges is 19. It means it start from 0.5, 1 mm, 1.5 mm, to 2.5 mm up to 9.5. Next is Next step is 10 to 90 and the step is of 10 mm. It means 9 slip gauges is there. It means 10 mm, 20 mm, 30 mm or up to 90 mm. And the last is 1.0005 mm. So there is no step. It means it is having only one piece of slip gauges. So summation of these number of slip gauges becomes 87. So that's why it is named as M87. This is a similar set, but the name is different. That is M112 set. It means it is having number of slip gauges, that is 112. Now the next question is that how we will use slip gauges. What is the method to use slip gauges to make the dimension? So these are the steps that how we will use slip gauges. First one is the always start with the last decimal place. If we want to provide a dimension, let us suppose it is 15.0235. So we have to start numerically from the last decimal place, that is 0.005. I will explain you with the help of numerical later on. And then take the subsequent decimal places. We have to use the minimum number of slip gauges while making a dimension so that there is a less chances of error and more accuracy. And in case of protector slip gauges, if we provided some protector slip gauge with the slip gauges, then what we have to do? Protector slip gauge are the slip gauge that are to be used at the end corners of a dimension. Let us suppose we have given with a 15 mm and we have to make this dimension with the help of slip gauges, and we have provided protector gauge of 2.5 mm on each corner at the last corner. So what we have to do, we have to subtract that protector slip gauge size from the total dimension. It means 15 mm minus 2 into 2.5. Because why 2.5? 2.5 is placed on starting of the dimension and 2.5 mm protector gauge is provided on the last corner. So from 15, this 2.5 and this 2.5 is get subtracted, and the remaining 10 mm we have to make it with the help of slip gauge. So how this is used? These are the steps in which we have to use how slip gauges are used to make dimension. So this is the example how the selection of slip gauge take place. So let us suppose we take the set of M87 and we have to make 49.3825 mm first dimension and second dimension 87.3215 mm. So what we have to do to make this dimension for making 49.3825 mm. So what is our first step? We have to start from the right corner of the decimal. It means we have to take this 5. So we have to take set M87, and according to M87, if we see this dimension, then the smallest value which is present here is 1.0005. So this value 1.0005 mm is present in the gauge set of M87. I will show you in the table. This 1.0005 mm is present. So we will take this slip gauge from M87 batch. So what we have to do? We have to subtract this 1.0005 mm from this dimension. So what dimension is remaining? 48.3820. We have subtract this from this. We will get 48.3820. Now again taking the right digit of the decimal, from this we can say that the minimum value is 1.002 mm. So this dimension is also present in M87 where from this set, from this range, there is a slip gauge of 1.002 mm. So what we do, we subtract 1.002 mm from this dimension. So we will get 47.3800. Now you can easily see that I have already told you that for more accuracy, we have to use minimum number of slip gauges. So I can also use here 1.08, but we can have the value of 1.38 according to the M87. You can see from this range, we have the slip gauge of 1.38. So we directly use 1.38 here. So we will subtract 1.38 from this dimension, 47.38. So we will get 46 mm. Now, what we have to do, we have no slip gauge of 46 directly in this table, 46 mm directly in this table, but we have the slip gauge of 6 mm in this range. So we will use 6 mm slip gauge from this table M87, and we will subtract 6 mm from 46. We will get 40, and size of 40 mm slip gauge is present in M87 directly from here, this from this range 10 to 90. So we get we directly use 40 mm, and here our dimension get completed. Now what we have to do, combination of slip gauges. Now we have to add these values of slip gauges, 40 plus 6 plus 1.38 plus 1.002 plus 1.0005, that is equals to 49.3825. In this way we can achieve the dimension by using the 5 slip gauges. Okay. Now the next dimension which we have to make is 87.3215 mm. So taking M87 table, we can make this with the help of that M87. So I think you get the idea of the selection of slip gauges. So here this selection of slip gauges is completed, and today's lecture is over. And in the next lecture we will discuss sine bar. So thank you so much and have a nice day. Thank you so much.